wanted to come back and revisit just the balancing of this equation and how the mole values work out. In this problem, we balanced the equation and said that one lead atom would need to react with 2 molecules of HCl to make 1 unit of lead chloride and 1 molecule of hydrogen. So we scaled it up mole-wise, and again, the reason we can do that is a mole of any of these is the same quantity, just like we could scale it up to a dozen. I also wanted to show just using the particle diagrams how this would work. If I wanted to say, maybe not make 4 moles, or start with 4 moles of lead, what if I just said 4 atoms of lead? Each one of those additional lead atoms is going to need 2 HCl molecules to react with. So I'm going to need to scale that up. If I want to make this reaction work with 4 lead atoms, I've had to scale this up now to 8 molecules. It's still a 1:2 ratio. It's a 4:8 ratio. And we can see how that would make 4 units of each of the products if we rearrange the reactant atoms into product. So again, maybe I'll show the lead chloride something like this. I'm going to need 2 chlorine atoms for every lead. Bring this last one over. And so I have made 4 formula units of lead PbCl2. Here's a PbCl2, here's a PbCl2, here's a PbCl2, and here's a PbCl2. Those would be formula units of PbCl2. And as predicted in my first part, I made 4 moles. Well, here I'm literally making 4 formula units of lead chloride, lead-2 chloride, PbCl2. And we would expect to make then 4 molecules of H2, and we can see how that works as well. Now we could drill all the way down to the particle like I'm doing in the diagram, but if I wanted to scale it up to a chemical quantity, I could take each of these units and scale it up by a mole. And that's exactly what we're doing with the mole concept here. We're counting up the number of particles that we're putting together to make each substance.